So here we have John has $40. He spent half of his money on video games. Sound like something you would do? 1/5 on snacks. Sounding like something you would do. And save the remainder. They want to know what percent of his money did he save. Okay, so if we have to work out this problem.
That sounds like me.
It sounds like you, exactly so. So if it is, we have to work out this problem. First of all, we have to take into consideration that we're dealing with some fractions up front, right? So they're asking us, right, to figure out the percent of his money that he saved. So an easy way to go about doing this question is this. Since they tell us that he spent half of his money on video games and 1/5 on snacks, let's find out how much money he spent, right? And we could do this question in a couple different ways. One way is to work out what is half of the 40 and 1/5 of the 40 and add it together and find the difference. Or we could add together the two fractions, right? Find out what that fraction is. Then we'll be able to figure out what is the fraction to represent the remainder. And we'll be able to calculate the percentage like that, right? So let's do what I would think might be the easier route for you, which is let's find half of 40 and then 1/5 of 40. Add those together and then we'll find the difference. So the money he spent on video games, right? If I ask you to find a half of 40, I'm telling you to multiply 40 by a half, right? What would we get if we work this out? What is a half of 40? So remember, whenever we're doing multiplication of fractions, what we want to do is look at the diagonals and cancel out any factors that are common. So is there any number that could go into 2 and go into 40 without leaving a remainder?
No.
Think about it. 2 and 40.
2 and 40.
Is there a number that could go into both of them without leaving a remainder? So, first of all, 40 is an even number. Remember earlier when we were playing the game with the prime numbers and I was telling you, we learned that even numbers are divisible by 2. And even numbers end in specific digits. If you could remember what those specific digits are, you might be able to figure out a number that could go into 40. So, the number 40.
42.
The number 40, it ends in a 0. What do you know about numbers that
4.
end in a 0? Okay, so you just say 4. 4 could go into 40, yes. But 4 cannot divide 2. Right? You'd end up getting a fraction. We don't want that. So what number, think again a little bit, since you figured out that 4 could go into 40, what other number you think could go into 40?
5.
Okay, keep going. Keep thinking about numbers that could divide 40. So 40 could be divided by 4. It could be divided by 5. What other number it could be divided by? 8. Alright, so I want you to stop for a
10.
second. And 10. So I want you to stop and think about this for a second, right? 4, 8, and 10 are all numbers that are divisible by what number?
2.
2. So do you think 40 could be divided by 2?
No.
Think about it a little bit. 4 is divisible by 2. 8 is divisible by 2. 10 is also divisible by 2. And they all have a common factor of 2. And they also could go into 40. So do you think that 40 could be divided by 2? Think about it a little bit. Remember I mentioned this as well earlier when we was playing the game. Sometimes there are other multiples larger than the 12th multiple that we learn up to. And that's one of the reasons why you will not see it on your list. But you just need to be able to recognize numbers that are divisible by other numbers. So 40 is divisible by 2 as well. So if I ask you to divide 2 and 40, right? How many times can 2 go into 2?
4.
Divide. Remember, the word into means to divide. So how many times 2 can go into 2? 2 into 2 is?
4.
2 into 2.
1.
1. There you go. And now we're doing the same thing with the 40. How many times can 2 go into 4 without leaving a remainder?
2 4.
Yes.
0.5.
No. How many times can 2 go into 4? 'How many times can we divide 4 by 2 without getting a remainder? Look at your timetable quick. 2. There you go. 2. And basically, 2 into 0 is 0, right?
Yeah.
What's 1 by 20? Was 1 by 20? All you have to do for me is multiply 1 by 20. Was 1 by 20? One times 20 is 20. Yes? Okay. Now let's do this last part, which is the part about snacks, and then we're going to do the percentage. So for snacks, they tell us he spent 1/5 of his money, right? So we're just going to figure out what is 1/5 of 40. So we're going to do the same procedure. We're going to multiply 40 by 1/5. So 5 and 40. If you check your 5 times tables, you'd see that 40 is
5 and 4.
there you go. 5 your timetables with 540 is in your timetables, right? So you're going to divide 5 and 40. So 5 into 5 is
1.
and 5 into 40.
8.
Very good. And now we're going to do the same thing we did earlier. We're going to multiply 1 by 8. What is 1 by 8?
1.
1 by 8.
8.
Right. Okay, so we want to know what percent of his money he saved. Now, they tell us how much he spent, right? So we just worked out how much he spent. How much money he spent in total?
1, 2.
How much he would have spent in total? So after you went, right? I was not gonna tell you that. After you went in the online store and you buy whatever video games, you spend half of your money. You spent $20 already. So then the remaining money, you went to buy snacks and you get 1/5 of your money worth in snacks. So you spend 20 and 8. So we add that together and we'll get 28, right?
28.
So you spent $28 in total. Tell me, how would we figure out how much money remaining? Because they said that the remainder is what he saves. So can you tell me how to calculate the money remaining? So after you went and you spent your $28, how much money you have remaining if you had $40 to begin with? if I ask you to tell me, after you spend your $28, right, how much money in your pocket still? What would you do to calculate that? If you had $40, right, and you spend $28, does that mean you have more money or less money? After you spend $20, you should have less money, right? So now you have $28 less than what you originally started with. So what is $28 less than 40? You'd have to take it away, right? So take away 40 and 28 for me. When you take away 28 from 40, tell me what you get.
68.
Take it away. Don't add it. Take it away. Remember, you're going to have less.
2.
12. 28 plus 2 is 30, and then 30 plus 10 is 40, so you get $12, right? $12. Now, to calculate the percentage, here's what we're going to do. We are going to express the remainder as a percentage of 40, right? So we're going to put 12 over 40, and we're going to multiply that by 100, alright? And basically we just need to break this down. So can you tell me, right? I'm going to start this off first by telling you 40 and 100 have a multiple of 10, and we could easily just cross off the zero. That's a little shortcut, right? We cross off the zeros. From here now, can you tell me a number that could divide any of these numbers here? So can you think of a number that could go into 4 and 12 without leaving a remainder? Or can you tell me a number that could go into 4 and 10 without leaving a remainder?
4.
4. 4 could go into 4 how many times? 4 into 4 is?
1.
Right. And what number can 4 go into without leaving a remainder? 12 or 10? Which one?
12.
12. How many times can 4 go into 12 without leaving a remainder? 3. So if we want to calculate the percentage now, I want you to multiply 3 by 10. What's 3 by 10? What's 3 by 10? Right. So our answer, remember we were trying to calculate a percentage, right? So we're going to state the answer as a percentage. So we're going to put a percentage symbol at the end here. So this is 30%. So what percentage of his money did he say? We're going to write the answer. The answer is 30%. Alright? So there we go. So that's how we do this question. And like I said, there's another way we could look at it as well, where we could add together the fractions, then find the remaining fraction and convert that into a percentage, right? So you have some options. Whichever one you feel more comfortable working with, you could do it either way, alright?